Page 12 of differentiation rules number 6. Consider the function f of x equals 2x cubed minus x. Complete the following table by indicating whether the function f dash, f double dash are positive, negative, or 0 at the given values of x. Okay, so let's find the first derivative and the second derivative. So the function is 2x cubed minus x. This is just a polynomial, so the second derivative and the third derivative are not difficult to do. The first derivative would be 2 times 3x squared minus 1, which would be 6x squared minus 1. The second derivative would be 6 times 2x minus 0, so it would be just 12x. Then I'm going to fill in this table. So what are the values when I plug in negative 1, 0, or 1? So let's start with negative 1. If I plug negative 1 into f of x, I would have 2 times negative 1, because negative 1 cubed is negative 1. So it would be negative 2 minus negative 1. So negative 2 plus 1, it would be negative. So I put negative here. Okay. When I put 0 in here, it would be 0 minus 0, which would just be 0. And then if I put positive 1 here, it would be 2 times 1 minus 1, so it would be positive 1, so it would be positive. What about the first derivative? If I put negative 1 in here, it would be 6 times positive 1 minus 1, so it would be a positive number, right? 6 minus 1. If I put 0 in here, it would be negative 1, so it would be a negative number. And if I put 1 in here, it would be 6 times 1 minus 1. It would be the same thing as the first one. It would be positive. Okay? 6 times 1 squared minus 1 is equal to 6 minus 1. It's positive, right? We're just seeing if it's positive or negative. We don't need the exact number. This is like a preview of what we do in the next chapter. Second derivative is 12x. So if I put in x equals 0, obviously it's 0. If I put x equals negative 1, it's going to be negative. And if I put x equals positive 1, it's going to be positive. So 0, positive, and negative. Okay. Number 7, given that f of x equals 2/3 sine 3x, show that the third derivative with 2 pi over 9 plugged in is equal to 9. Okay, so let's not see that it's 9 yet. We're just going to take 3 derivatives and we're going to plug in 2 pi over 9 and see if we get that. Okay, so let's find the first derivative. The first derivative, we just leave 2/3 as the coefficient there. We take the derivative of the outside function, which is derivative of sine is cosine, and we leave the inside the same. Then we take the derivative of the inside, chain rule, and our result is 2 cosine 3x. That is our first derivative. Second derivative, let's take the derivative of 2 cosine 3x. We leave the 2 there. The derivative of the outside function, cosine, is negative sine 3x, and then we do chain rule on the inside function, so it would be times 3, so it would be negative 6 sine 3x. Okay, so now let's plug in 2 pi over 9. If we plug in, oh, we don't have the third derivative, this is only the second derivative, sorry. F of 3, third derivative, it would be negative 6, we just leave the coefficient there. We take the derivative of sine as cosine. We leave the inside the same. And then we do the chain rule on the inside. It would be 3. So it would be negative 18 cosine 3x. Sometimes I'm bad at writing 3's, even with the Apple Pencil. Okay, now I'm going to plug in x equals 2 pi over 9. So it would be negative 18 cosine of 3 times 2 pi over 9. These cancel out. I'm left with negative 18 cosine of 2 pi over 3. What's 2 pi over 3? It's this triangle here. The cosine is the short side, so it'd be negative 1/2. So it'd be negative 18 times negative 1/2, which is equal to positive 9. Now if we go back and check the right-hand side, yes, it was positive 9, so we did it. All right. Now let's do the next problem. They want us to show that the first derivative is equal to this. Let's cover it up. Okay, first I'm going to rewrite the original function so that it's a little bit more obvious that the cube is the outside function. Okay, now I'm going to find the derivative of this function, the first derivative. I leave the 2 as is. I bring the 3 down because I'm doing power rule. The 3 becomes 3 minus 1, and then I do chain rule on the inside function, which is sine of x, and I get cosine of x and multiply it. Then I do the derivative of the second part. So I leave the coefficient as is, and I find the derivative of sine x is cosine x. No chain rule there because there's no function inside of a function. Simplifying, 6 sine squared x cosine x minus 3 cosine x. Okay, now let's check to see if we got the same thing. Oh, not quite, because they have a identity here. Okay, now remember this identity, there's 3 options. There's cosine squared minus sine squared. There is 2 cosine squared minus 1. There is 1 minus 2 sine squared. Any of these look familiar? Not sure, but let's do this. Let's factor out this common factor, and maybe that'll help. Cosine x factored out, 6 sine squared x minus 3. Ooh, let's factor out a 3 too. 3 cosine x, 2 sine squared x minus 1. Oh, now it really looks like this, right? The only difference is it's backwards. So this is equal to negative cosine 2x. So now I can do the last step. Negative 3 cosine x times cosine 2x, and I'm done. Okay. Then it says to find the second derivative. Oh my gosh. So this was the first derivative. Let's find the second derivative. The second derivative would be a product, right? So if this is a product, then this, ooh, sorry about that. This is u, and this is v, and we'll just leave the negative 3 off to the side, and we'll bring it back at the end, okay? So if u is cosine x, then u dash is negative sine x, right? And if v is cosine 2x, then v dash is negative sine of 2x chain rule times 2. I'm going to rewrite that. Negative 2 sine 2x. Okay, now I'm going to multiply this, negative sine x, times this. And then I'm going to multiply this, negative 2 sine 2x, times this. And then at the very end, remember, I do need to bring the negative 3 back in. Okay, so I'm going to have negative sine x times cosine 2x. And I add that to negative 2 sine 2x times cosine x. And then I multiply everything times negative 3 because I had set that off to the side. Okay, and I can like make everything positive now. Okay. 3 sine x cosine 2x plus cosine x 2 cosine x sine 2x. Number 9, find the second derivative given that y equals x natural log of x. Okay. So x natural log of x is a product. This is u, this is v. U dash is equal to 1. V dash is equal to 1 over x. I'm going to, multiply this times this and this times this. Okay, so the first derivative is equal to x times 1 over x plus 1 times natural log of x, which is equal to 1 plus natural log of x. Interesting. Second derivative is equal to 0 plus 1 over x. Interesting. Okay, so the second derivative is 1 over x. C, if I have y equals natural log of x squared, this is a function inside of a function. So the first derivative would be the outside function. Inside function remains the same. Exponent goes down to 1. Derivative of the inside function is 1 over x, so 2 natural log of x over x. The second derivative of this is a quotient. Since this is a quotient, the top is u, the bottom is v. I'm just going to leave the 2 off to the side, okay? So u dash is equal to 1 over x. V dash is equal to 1. So now we're going to have to do quotient rule. Remember, quotient rule is going to be v squared on the bottom, vu dash on top, uv dash minus uv dash. Okay, so the bottom is going to be v squared, which is x squared, and x times u dash, which is 1 over x, minus u, which is natural log of x, times v dash, which is 1. Okay, so we're almost done. Remember, x times 1 over x is just 1. So now we have 1 minus natural log of x over x squared. That is mostly done. The only thing we need to do is we need to multiply everything times the coefficient of 2. So it's actually equal to 2 times 1 minus natural log of x divided by x squared. And now we're finally done with the second derivative of natural log of x quantity squared. Okay, remember how we talked at the end of page 11 about in nature, a lot of the population ends up being an exponential function because exponential functions are a derivative of itself. Here's another example of that. When you go to college, if you go to college and do calculus in college, up to 4 semesters of calculus, then you'll eventually do these kind of problems. I guess they want you to see this. Not that you're going to remember it, okay? But if you have exponential functions and you take multiple derivatives of the exponential functions and add and subtract them together, you can get everything to cancel out. And that's the idea of the 4th semester of calculus. It's called differential equations. Okay, so it says show that this is equal to 0. Forget that this is 0. Just like do this and you'll end up with 0, okay? So we're going to find the first derivative. We're going to find the second derivative. We're going to multiply by -7, blah, 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 multiply by 12. We're going to add everything together and they'll perfectly cancel out. How interesting. Okay, so first we're going to find the first derivative. The first derivative, just leave the coefficient there. The derivative of e to the 3x is e to the 3x. Multiply times the chain rule, 3. Derivative of 5e to the 4x, we leave the coefficient there. We just rewrite the exponential function because the outside function is exponential. We take the derivative of the inside, which is 4. Now we simplify. 6e to the 3x plus 20e to the 4x. So this would be our first derivative simplified. What's the second derivative? The second derivative would be 6e to the 3x times 3 plus, is this a 20? 20e to the 4x times 4. And then if we simplified, it would be 18e to the 3x plus 80e to the 4x. Okay, so this is the second derivative. This is the first derivative. And of course, the original function is this. Now what we're going to do is we're going to take the second derivative, which is 18e to the 3x plus 80e to the 4x. And then we're going to subtract 7 first derivatives. The first derivative is 6e to the 3x plus 20e to the 4x. And then we're going to finally add 12 of the original function. 2e to the 3x plus 5e to the 4x. And then we're going to add all that up and see what we get. So we have 18e to the 3x plus 80e to the 4x. And then we're going to shower negative 42e to the 3x minus 140e to the 4x. And then we're going to shower plus 24e to the 3x plus 60e to the 4x. What does that equal to? Now we can combine like terms. So how many e to the 3x's? We got 18 plus 24, which is 42, minus 42. Oh, they cancel out. What about e to the 4x terms? 80 of those minus 140 plus 60. Oh, they cancel out too. So it does equal 0. Okay. So when you get to the fourth semester of calculus, you are not going to have the answer already. You are going to get this equation, and then you're going to use algebra to figure out the answer. In this case, since you don't know how to do that yet, what they did was they gave you the answer, and then you confirm that the answer actually works, which is kind of boring. Okay? All right, number 13. Trig functions also kind of have a similar property as exponential functions, because exponential functions, if you take a derivative of it, you get itself, right? So then it appears in nature a lot because, you know, if the rate of change is equal to the amount of stuff you have, then that basically would be an exponential function. Now, when does that happen with trig functions? Trig functions, the derivative of a trig function is not itself, but if you take multiple derivatives of a trig function, you eventually get itself, and we're going to see that right now, okay? So the original function sine x, what's the derivative of sine x? We know it's cosine x, right? What's the derivative of cosine x? We know it's negative sine x, right? And what's the third derivative of this function? I don't know how to write that. It would be negative cosine x, right? Because the negative just stays, and then the derivative of sine is cosine. Okay, and what about finally the fourth derivative of sine x? The derivative of cosine x is negative sine x. So right, negative of negative sine x is just positive sine x. What do you know? We get what we started with. So it's like a cycle, right? If you take 4 derivatives of sine, eventually you get sine again. So we have just shown that the fourth derivative of sine x is equal to sine x. And so we have proven what they asked.